Now that we have derived the quadratic formula, we're going to use it to solve a quadratic equation. And that's the beauty with the quadratic formula. You can solve it regardless if it's factorable, and it saves a lot of time. You don't have to complete the square. So any quadratic equation that you're given can be solved using the quadratic formula. And really all we need to do is to, one, know the formula, so you will have to memorize it, and two, just figure out what A, B, and C are and plug them into your formula and then simplify. A question that you'll be asked on your exam and on your final exam, you'll be asked to use the discriminant, which will come up in a later section. You'll be asked to use the discriminant to describe the solutions. This isn't complicated, because if you know what the quadratic formula is, then you know what the discriminant is. The discriminant is the part of the quadratic formula, just the part under the square root. It's not the square root included, it's just the part under the square root. And remember, this is the part that determines whether or not we have real or complex solutions, rational or irrational, and it tells us how many solutions we have. And the reason why it tells us all that information is because it's the part of the formula that's underneath the radical sign. So if it's a negative number, and we have a negative under the radical, we'll have complex solutions. If it's a positive number, then we know we'll have real solutions. So it's really the only tricky part of the formula, and since it's under the square root sign, it really determines quite a lot about the solutions to this quadratic equation. So I will write it down. I'll write b squared minus 4ac, and I'm just going to plug my values of b, a, and c. And remember, these are just the coefficients when your quadratic equation is in standard form. So you need to make sure everything is on the left and you have 0 on the right. You need to make sure you have that. And then we can clearly see that my a is 1, my b is 3, and my c is minus 1. So when I plug them into this formula, you'll get 3 squared minus 4 times 1 times negative 1. So we'll get 9 plus 4, which is 13. Since this is greater than 0, then we know that we're going to have 2 real solutions because it's a positive number. We also know that since 13 is not a perfect square, then that square root of 13, because the 13 is going to be under the square root, that's not going to factor very well. We're going to have an irrational solution. So we're going to have 2 real, and in fact they're going to be irrational because it's not a perfect square. The good thing about solving for the discriminant first is actually you already have a piece of the quadratic formula. So when you go to actually solve for the missing solutions, well, we plug in b and 2a, and that's, or the opposite of b and 2a, and that's really all we have to do. We'll have minus 3 plus or minus the square root of the discriminant. Well, we figured that out to be 13 all over 2 times 1. So we're going to get x equal to opposite of 3 plus or minus the square root of 13 all over 2. And I specifically chose this because this is the exact problem that I solved in the last podcast using the completing the square method. And you can see we obviously get the same solution that we did before, took a little less time, and we broke it apart into first, even before we used the quadratic formula, by learning the discriminant and using the discriminant, we knew what kind of solutions we would get. And now that we have our solutions, we plug them into the formula. In the last example, we actually left it apart into 2 separate pieces. So I would accept this answer since this is, we can't really simplify this anymore. But I would also be okay with you breaking it apart to being minus 3 halves plus or minus root 13 all over 2. Either one of these solutions I would be okay with. And typically, actually, this last one is used because we want to make sure, if this minus 3 was a 6, or if there was a 4 in front of the 4 or the root 13, we would want to break it apart and factor out, just in case we could have factors that cancel. So the discriminant tells us how many roots there are. if they're real or complex, and if they're real, it also tells you whether or not they're irrational or if they're rational. And then once you do that, and if you do that first, then you already have a piece of the quadratic formula done, the b squared minus 4ac. And you plug all the remaining numbers into the formula, you solve, and you get your solutions.